welcome everybody. I'm Stephanie. I'm on the East Coast time zone. For me, it's 10 a.m. It's a lovely time to be starting a workshop. Bethany, do you want to say hi?
Yeah, hi everyone. As people have said, I am Bethany Bray here in Chicago. I think Stephanie told all the great stuff about us. I work in latent class modeling. I'm particularly interested recently, or not so recently actually, in the application of these methods in health equity applications, particularly queer health equity, but also health equity broadly speaking. So if any of you are interested in that, happy to talk more. I am also sort of the technical troubleshooter for the day. So please let me know about that. And it is 9 o'clock here in Chicago, which is an okay time to start a workshop. I am not a morning person, hence the coffee. Yeah, I think that's all. That's good. You'll get to know us quite well. As Stephanie said, we're best friends, so it's a little bit of the Stephanie and Bethany show. You don't have to laugh at our jokes if you don't find them funny. It's okay.
So typically these workshops have one instructor, so you get two for the price of one here.
So before we jump in, I just want to make sure that everybody is aware of everything that'll be going on. So we're going to really briefly talk about three things. The first is the set of files that Stephanie and I shared with you. Hopefully everybody was able to download that. And as a note, if you have not officially extracted the files out of the zip file, I highly recommend you do that to your local drive. It can be easy to copy and paste or to just open them from the zip file and forget that you didn't extract them. A lot of the times the software programs won't read them correctly if you don't officially extract them. So you might want to take a minute if you haven't already. And hopefully the files are well labeled and you were able to navigate. But just in case, just really wanted to show you briefly what we've provided. The agenda is sort of a loose agenda. We will proceed through the topics as indicated on that agenda. But as you move forward after today's workshop, the agenda also includes a brief recommended reading list that we may refer back to occasionally. The first set of readings on that list are some applied examples that Stephanie and I have worked on over the years with collaborators. And then the second set are different methodological articles that people have asked us about over the years. So there's an article, a very brief, nice article in there comparing latent class analysis to cluster analysis, for example. There are 3 articles on power analyses if you're writing grants, things like that. So it is not exhaustive, but it's a great place to get started as you move on from today. The exercises are all labeled. We'll work through them one at a time. And for the ones that involve coding, we will be providing a demo on how to get those to run when we get to that point. But the exercises are considered quote unquote homework for those of us not in school anymore. So I have them labeled with the days on which you should work on them. So we're going to cover 3 of those exercises today, 2 tomorrow, and then 2 on Saturday. For those of you who are using a variety of software packages, we're going to talk about those in much more detail later once we get to that part. We are focusing in this workshop on M+, but we recognize not everybody uses M+. And so although there are quite a few materials posted, for the exercises for which it's relevant, we've also included additional information about software packages. Stephanie and I are SAS users for the most part. So SAS, M+, and Latent Gold are ones that we feel pretty comfortable supporting. Neither of us are Stata users. And so if you are a Stata user, please note that there are 2 versions of Stata. There's a plugin that we sent, and then there's also the native version of Stata. So if you are a Stata user and you're experiencing some issues in Slack, there's a special channel called Stata_users, I think. So please feel free to crowdsource some help there if you are a Stata user. Readings, we just provided a handful of readings that we get asked about a lot. You are also able to download these, from like Google Scholar or your university. You can have a look at those. All three of these are on the reading list. They're really just for your benefit. And hopefully you had some time to look over the handbook chapter, but if not, that's okay. For the slides, we provided the lecture slides both as a PDF and as PowerPoint just in case. And then for those of you who maybe like hard copies or like to take notes on more of a notes format, I also provided it as a lecture handout. And these are all just files for us. So that should be everything in your folder.
So we have a couple of goals. So of course we want to elevate your level of mastery in using this technique in your own work. That's the primary goal of these 3 days. We would love, to the extent possible, to help you build a community of people that you meet online here today who work in a similar area. Maybe people you could reach out to in the future with questions or even a collaboration. At the end of the day, Bethany and I are very pragmatic. We're here, we're informal, we'll take questions openly. Our goal and what will be the best outcome of these 3 days together is if by Saturday, 3 days from now, the end of the workshop, you have new ideas of analyses that you want to conduct with data you've got access to already or you're about to collect. And even better, you have ideas for writing grant proposals that might adopt this statistical technique to learn new information from data that you've already analyzed. If you are in the US, the National Institutes of Health will provide grants just to do secondary data analysis. Learning a new technique like this is a great opportunity to go after external funding if that's of value at your institution. But just to learn new information from all the heaps of data we've all got access to. So we really hope that some ideas will spark. So look for people that have similar kind of content areas that they're interested in, and I think we'll learn from each other. I'm going to jump into the lecture. I will just say that, yes, Bethany's fun fact is fun. I will just say that my research and a lot of Bethany's too has been funded by the National Institute on Drug Abuse at the NIH, and that goes back for decades now for us. So you're going to see a lot of examples in the area of substance use behavior that, as you'll kind of get a feel for today, that area really lends itself well to this technique. But, take your construct of interest, your data set of interest, and kind of substitute it for what we're talking about, and hopefully you'll see how it's really broadly applicable. We will talk about other examples too, but I just wanted to explain the reason why we have so many substance use examples is merely a fact of our support from the National Institutes of Health over the years. Okay. And one other kind of comment, as we walk through different techniques, you're going to see a lot of times where Bethany and I pause and we restate the research questions and kind of come back to them after we run analyses. And it will look like pieces of our lecture will hopefully feel like we're walking you through an empirical paper that uses this technique. By the end of even today, I think you'll have a really good sense of what the flow of an empirical paper using this technique would look like, what format of the tables you might plan to lay out. So we want to help you get started in writing your first LCA paper if you're new to the technique, and get you up to speed as quickly as possible. Awesome.
That's us.
That's
Today's
all.
the day.
That's right. It is February 24th. Shocking. Okay, I'm at Penn State, East time zone. Bethany's in Chicago, 1 hour later. We're here to talk about LCA. So latent class analysis, LCA. Okay. Let's jump right in. And again, feel free to keep your videos on. We love to see your faces. Shut them off if you don't want to be seen. We don't mind at all. If you have questions, again, feel free to post them in the chat, and we'll be trying to monitor that. But also, if you're able to unmute and speak up, that's also fine with me. So please feel free. Let's see. As far as the chat window, good. Looks like people are posting and no questions, so I'll keep an eye. All right, let's jump in. So this is a really broad overview of what we're going to do across 3 days, okay? We're going to start out with a very conceptual introduction to latent class analysis. And we'll do this through one empirical example that we've talked about many times. Bethany and I have used this example many times, and it's about adolescent alcohol use behavior, adolescents in the United States. And one thing that's a hallmark of this example is it is very, very clean. It's neat, tidy, and clean. So you won't really see this in the real world, and we'll explain why, but you're going to see a really nice, neat example. You'll see messier examples later in our course. Once we get through kind of the conceptual underpinnings here, we're going to jump into what are the parameters that are being estimated in a latent class model and really spend time on technical considerations. So when we jump into a latent variable model like LCA, we always have to be attending to 2 things: model identification and model selection. And those 2 things kind of go hand in hand. We're going to present them in a particular order, but it doesn't matter which order. We need to ensure that our model is statistically identified. And we also need, from our identified models, we need to select our best model. Something you'll hear again and again these 3 days is, and this is true in statistics at large, is no model is right. There is not one correct model when you're analyzing real data. No model is right, and no model is true. But some models can be really helpful. And so when we talk about model selection, we're just trying to do the best we can to choose the best model we've got. And so we'll talk about the parameters and model identification and model selection. Then we're going to spend some time this afternoon really talking about software options, and that'll be a great time, I think, for us to see, for those who are attending who really want to get hands-on experience over these 3 days. This afternoon's the time. Get into your software package and let's get everybody up and running as much as we can. As Bethany said, we'll do our best to help you if you're using M+, SAS, Stata, and Latent Gold. Okay, so that is really what we're going to focus on today. Okay, next, please. All right, so then tomorrow we're going to dig into 2 really important topics. These first 3 bullets here. We're going to get into a grouping variable. So by the end of today, you're going to know how to do a latent class model, how to interpret it, how to select it, what the statistical properties of it. That's all going to happen today. Tomorrow, we're going to start to introduce more. We're going to add grouping variables, like maybe there are differences in latent class membership probabilities in a control group and a treatment group, a grouping variable. And then we're going to take a step back and do kind of brush off the cobwebs and do a review of logistic regression so that we can move into a really important topic, which is we call it LCA with covariates, or predicting latent class membership. So we're going to add predictors or covariates into our LCA model. So tomorrow, those are the 2 big topics: grouping variables and covariates. And that will allow you to really open up the questions you can ask with latent class analysis. And then finally, on Saturday, we're going to move into this topic of predicting an outcome from a latent class variable. That's a completely different statistical challenge from LCA with covariates. On Saturday, we'll be predicting an observed outcome from a latent class variable. And the other thing we'll do on Saturday, which didn't make it on our list, is we really built up our content so you understand latent profile analysis. So on Saturday, we're going to cover distal outcomes and latent profile analysis. And we'll talk more about that as we go. Okay. All right, so let's keep in mind these abbreviations. We're going to use them a lot, especially the first two. LCA stands for latent class analysis. So when we have a latent class variable, we're talking about a categorical latent variable. And it's measured by observed variables. So if the observed variables are categorical, that model is called LCA, latent class analysis. We have a categorical observed variables predicting or measuring a latent class variable. If instead our indicators, our items, our observed variables are continuous variables, you can also use continuous variables to model a latent class variable, a latent categorical variable. That model is called latent profile analysis. So it's the observed variables metric, and categorical is latent class analysis, continuous is latent profile analysis. So we'll talk about LPA on day 3. And then there's another topic that you'll hear us mention, but we're really interested in developing a separate workshop that digs into latent transition analysis, LTA. So LTA is when you have repeated measures data and individuals can transition in their latent class membership over time across time points in repeated measures data. So that's LTA. So today is all about LCA. So let's get into that.
Stephanie, before you move on, could you comment a little bit about the different language that people might read about that refer to these same models?
Yeah. So I mean, feel free to pipe in, Bethany. So there's this in the statistical literature, and I think this is what you're getting at. In the statistical literature, there's a technique, a set of models called finite mixture modeling, FMM, finite mixture models. Finite mixture models are all sorts of models where the goal is to partition individuals into subgroups, that is using a latent categorical variable. So there are a lot of different ways that you can consider a finite mixture model. That includes LCA, LPA. It also includes growth mixture modeling. If you are really into using M+ for growth mixture modeling or SAS-proc trajectory for group-based modeling, that's also a finite mixture model. LTA is a finite mixture model. You can have mixture regression models where regression coefficients are used to partition people into subgroups. So finite mixture modeling is the big umbrella. And we're going to be talking about specific types of finite mixture models. Bethany, anything else with terminology?
Yeah, I think the only other thing I wanted to add is that there's nothing particularly special about the words that we're using here. When Stephanie and I talk about latent class models, we're almost always referring to all categorical indicators in the latent class model. If we're talking about latent profile models, we're almost always talking about all continuous items in the model. There are also mixed indicator models that have both categorical and continuous. However, all of those models can be called finite mixture models. All of them can be called latent class models because the latent variable is categorical. Some people might call all of those latent profile models. Latent Markov models is another word for latent transition analysis, which we won't be talking about here. So just don't let the terminology get you bogged down. Really what's critical is the fact that we're looking at a categorical latent variable as opposed to a continuous latent variable like you would in factor analysis. That's all.
That's right. Yep, that's great. Fantastic. Yes, I know there was a lot of confusion when people started doing growth mixture modeling in M+. There was already a SAS-proc for doing group-based trajectory models. Those are essentially the same thing, totally different names. So it gets confusing for the user. So ask us any questions, clarification. And And if you are a growth mixture modeling person and you want to get expertise in LCA more broadly these 3 days, ask us at some point. We can talk very directly about how growth mixture modeling fits into this framework of finite mixture models. So these models are all kind of connected. So, okay, so let's get into a conceptual introduction. Remember, I said this model is going to be very neat and tidy. That also implies it won't be like terribly interesting and earth-shattering. The classes will be very like, yes, that makes sense. So let's move into that example. So when we fit a latent class model, like first and foremost, why are you here today? Why do we do LCA? The basic idea of LCA has to be that individuals or units of some type, we'll just talk about individuals, can be divided into subgroups based on some unobservable construct. Okay, so the construct that we want to divide people into is unobservable, and because it's groups of people, it's categorical, just naturally categorical. So those subgroups are called latent classes, and it's unobservable, meaning the true class membership, which group someone is in truth is unknown, and it can't be known because it's unobservable and latent. So it's unknown due to measurement error. And so we've got to figure out how to measure subgroup membership while taking into account measurement error. How do we do that? We triangulate on likely subgroup membership or latent class membership using multiple categorical indicators or observed variables. And part of the premise of LCA, a fundamental premise, is that the latent classes or these subgroups are mutually exclusive and exhaustive. So that means everybody's in exactly one and only one of the latent classes at that time point. Again, this is just the statistical theory behind LCA. So if you're familiar with factor analysis, you're going to see a lot of analogous concepts here. So if you are familiar with factor analysis, if you're not familiar with factor analysis, don't worry about it. But if you are familiar with factor analysis, maybe some of these analogies will be useful for you. So LCA is similar to exploratory or confirmatory factor analysis. In factor analysis, your underlying factor is a continuous latent variable, right? And everyone supposedly has a factor score. In LCA, the latent variable is categorical, and everyone is in one and only one of those subgroups in theory, okay? And your job in factor analysis is to measure the factor or see how many continuous latent factors are required to represent your data. In LCA, our job is to determine how many subgroups are needed to represent the people in our data set. Okay. So we'll come back a few times and touch on connections with factor analysis as it's useful. Okay, so LCA. So now we have an idea of kind of the general premise of why we're here, why we would want to do this. And remember, if subgroup membership, why does it have to be unobserved? Well, if it was an observable subgroup, then you can ask people on a survey or look it up in the data and know what group they're in. And there is no latent variable to deal with, right? You're in this group and they're in this group and you're done. It's the fact that we can't just simply ask people a question and put them in a group that makes it a latent class variable. So we have to now deal with measurement error, all that fun stuff. Okay, so in that light, let's talk about the sets of parameters estimated in LCA. So we're going to start really basic here, and it's relatively simple. There are two types of parameters estimated in LCA, two general types of parameters. One is latent class prevalences, and those latent class prevalences reflect the probability of membership in each of those latent classes. And Another way to say it is the proportion of people in your population expected to be in each latent class. How big are the classes? That's really what we're talking about. As you can imagine, we said they're mutually exclusive and exhaustive. So the prevalence of those classes would have to sum up to 1.0. So we'll come back to that. So that's usually our point in measuring a latent class variable is so that we can describe the latent class variable. Part of that description is what size the classes are. That's the latent class prevalences. But what characterizes those subgroups or those latent classes are reflected in the item response probabilities. So this is the second set of parameters estimated in LCA, item response probabilities. In our book, we refer to latent class prevalences as gamma parameters, the Greek symbol gamma, and we refer to the measurement parameters or the latent class measurement parameters as a rho, the Greek rho parameter set. So we'll come back to the parameters when we get into the mathematical model. But that's enough to get us going. We've got two sets of parameters, right? So let's take a look at our simple example. So this example of LCA, so it's I guess getting a little dated now, but this was from data from the National Longitudinal Survey of Adolescent Health, or AdHealth. And we took a depression scale that was measured among a large sample of adolescents in the US. And there were 8 depression indicators, 8 symptoms of depression that we pulled out of this data set. So we had 8 indicators of depression latent class. Okay, so if we have 8 indicators and we code them as binary, in the past 2 weeks, did you feel like you couldn't shake the blues? Yes, no. In the past 2 weeks, did you feel depressed? Yes, no. Okay, we have 8 items like that. That means that we have 8 binary indicators of our depression latent class variable. And so that means we have 2 to the 8th possible response patterns, right? So each adolescent in the sample had 256 possible ways they could respond to that set of 8 items. They might have said yes, 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 no, 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 or they might have said no to everything, right? Or yes to everything, or anything in between. So the 8 items, just based on sort of face validity, to us, the 8 items looked like they kind of clustered. Couldn't shake the blues, felt depressed, felt lonely, felt sad. We also, those ones kind of sounded like sad. There were 2 symptoms. People are unfriendly to me and I feel disliked by people. And those are kind of sound like they're disliked or it's interpersonal. And then 2 more extreme items. Life was a failure. Life was not worth living. So those ones sounded a little more extreme. But it was just a list of 8 items that to us looked like they clumped in this way. Do the items need to be binary? No, they do not. So we're starting simple this morning, and everything is going to have binary distributions on the indicators. All 8 are binary. You can have 3-level categorical variables, 4-level categorical variables, and more. Things to note are that they are treated as, typically, almost always, they're treated as nominal categorical response options rather than ordinal. Ordinal indicators is a more complicated model. It's very seldom used. So even if you had a low, medium, high on each item, typically we would still treat those as nominal and unordered, which sounds a little bit maybe counterintuitive, but the statistical model with ordinal indicators is pretty complex and we don't tend to go there. If you have too many categories, you start to have identification problems, which we'll talk about. So if these were all 3-level items, we would have 3 to the 8th possible response patterns. So imagine how sparse your data table will be. That's right. I like Rebecca's motioning. Yes, very sparse. So that's right. And then if there are too many categories, maybe you should think about treating them as continuous variables. And that would be latent profile analysis, which we'll talk about on Saturday. Okay, great question. Keep them coming. Okay, so coming back to our depression example, I'm going to show you some quick results and skip over the model identification and model selection parts. We're just going to get to the answer here. So we selected 5 latent classes of depression. So again, these are mutually exclusive and exhaustive in theory, which means that the prevalence or the percentage of the population expected to be in each latent class will sum to exactly 100%. The classes we identified were the no depression class, the SAD class, the disliked class, the SAD and disliked class, and then the class that we called depressed, which is they were elevated on the SAD items and the disliked items and the failure items. So you'll see 41% were in the no depression class. So the majority of adolescents were in some level of depression symptomology, and only 9% were in that full-blown depression latent class. Let's see, I'm going to peek at the chat, discovering a latent class for the responses. How is it different from creating a scoring system based on the sum of responses and categorizing based on the score? Okay, so that is a great question. So we have a couple of papers where we look at exposure to different risk factors, and we identified latent classes based on the different exposures to risk factors that an adolescent might be exposed to, right? And we did a sort of a head-to-head comparison about, well, what if we just sum up the number of risk factors out of, say, 8 that an individual is exposed to? Excuse me. And that's called a cumulative risk index. It's what people call that. And so you can just sum it up as a scoring system, or you can use LCA to identify particular subgroups of people that have different configurations of risk exposure. And so what you get if you just sum them up is a quantitative number for, if you have a yes on 4 items, it doesn't tell you which 4 items. If you use LCA, then it's going to tell you exactly what configuration of indicators people tended to say yes to and tended to say no to. So we can come back to that. Ashraf, I don't know if that fully answers your question, but we could definitely come back to that and also recommend a paper that does sort of a head-to-head comparison about summing up the number of indicators versus using LCA. Okay, let's get back to our depression example. So remember, we just showed you the prevalence of the latent classes. So that is our first set of parameter estimates in LCA. The other set was our probability of each response category for each item conditional on latent classes. So that's a mouthful. We're going to unpack that. Great. So we're going to unpack what I just said a little bit. So the item response probabilities, or the measurement parameters, these are analogous to factor loadings if you do factor analysis. So this matrix of probabilities links your observed indicators, which are shown in the first column. We have 8 indicators, and it maps these indicators onto our latent classes, which we usually organize it this way. They're shown in the columns 2 through 5. 2 through 6, columns 2 through 5, 2 through 6 for classes 1 through 5. That's terrible. Okay, so this matrix is really important. This tells us what the classes mean. The previous slide only told us how big the classes were, but this tells us what are the characteristics of people in that class. And this is what reflects measurement error, right? So in LCA, our goal is to estimate the class prevalences, which we just looked at on the previous slide, after addressing measurement error, which is reflected in this slide. Okay, so let's unpack this just a little bit. Let's look at class 5. So we told you we labeled them depressed. Why did we label them depressed? We knew that 9% were expected to be in this class from the previous set of parameter results, parameter estimates. But we have to look deeply into this slide to understand why we call them depressed. So what are we looking at? Let's look at that 0.90, right where the cursor is. So that reflects the probability of saying, yes, I have felt depressed in the past. Sorry, yes, I could not shake the blues. The probability of endorsing that first indicator, could not shake the blues, given that I'm in latent class 5. So people in latent class 5 have a 90% chance of reporting that they could not shake the blues. They have a 100% chance of reporting that they felt depressed, a 92% chance that they feel lonely, and so on, all the way down to the last item, which is life is not worth living. They have an 85% chance of even saying that. So the probability of endorsing each depression indicator, each symptom in the past 2 weeks is very high, well above 0.5 and approaching 1.0 for individuals in class 5. That's how we got the label depressed. Okay, and so let's just let's look one previous class 4. We called that the sad and disliked. Why? Because they have very high probability of endorsing items that reflect sadness and feeling disliked, or that people dislike you, or that you dislike people, or sorry, people are unfriendly to you and you feel disliked. But they have a very low probability, 0.23 and 0.10, of reporting life was a failure and life was not worth living. So these adolescents may be at really important risk for the development of suicidal behaviors, perhaps, but they don't fully endorse that life was a failure and not worth living. Individuals in class 5, however, we would be even more concerned about those adolescents. And so if you think about, if you had instead summed together the 8 items, how many did you endorse? If someone had endorsed 6 items, in this example, probably they might have been those first 6 items, but not necessarily. It doesn't tell you which 6 they endorsed. So again, this is a nice clean example. So let's move on from here. So that, yeah, please.
Wanted to add 2 things kind of in
Please.
response to Ashraf's question. So if you think about maybe a clinician who uses a total score to determine whether somebody is clinically depressed or they're not clinically depressed, that might turn out to be only people in class 5. But if you want to implement an intervention for people who are at risk of becoming depressed, this can also give you information about those subclinical folks. And also, if you notice, participants in class 2 and class 3, although they endorsed a different number of items, they both only endorse items in one dimension. And so these classes are not, they're not necessarily ranked ordered in terms of their risk for maybe an adverse outcome or transitioning to depressed. So is it the folks who are sad, or is it the folks who are disliked who are at greater risk of later in time becoming class 5? So I just wanted to point out a couple of differences in the cumulative score and kind of these different configurations.
Mm-hmm. Any further questions? This was our very, first example we walked through. We're going to move into another example. So this is actually the one that is pathologically neat and tidy. So you'll see a very simple model here. So let's walk through another example, but keep the questions coming and feel free to interrupt anytime. So this example is about alcohol use in the US, 12th grade is a high school senior. It's the last year of high school. Drinking age is 21, so it's illegal to use in 12th grade. So we're going to be reporting on an analysis here that is it's from 2004, so it's actually 20 years old. Wow. I think I must have run this one in graduate school. Interestingly, they're still collecting the same data every year, so we could replicate it for 2024 data and see if it looks different. It very well might. Although drinking rates haven't changed that dramatically in the US. So this is data from a one cross-sectional data set, a cohort of monitoring the future data. That's a famous public health data set in the US that focuses on substance use. And the sample here, and we will revisit sample size these 3 days, and we can talk a little bit about statistical power. This is a pretty large sample, 2490 high school seniors. I have, and I know Bethany has published LCAs with as few as 100, 150 people. If you have fewer than 100, it can get pretty tough, but we can talk about conditions where that might still work. So this is a pretty large sample, 2490 high school seniors, and they were collected in a way to reflect the national distribution across sex and race, ethnicity. And so here are the study goals. So here's like the first time we're going to show you some research questions as we might write them in an empirical paper. So the goals of this study are threefold: to model and describe alcohol use behavior among high school 12th grade students in the US. So to describe the behaviors, the patterning of behaviors. Second goal will be to look at gender differences in the measurement of the behavior and in the behavior itself. So we're going to look for gender differences between male and female seniors in the measurement parameters, and then in the prevalence of the classes. And so that's a grouping variable question. So we'll walk through that tomorrow morning. And then we're going to move into a covariates question, which we will address tomorrow afternoon, which is to predict drinking behavior class membership from 2 covariates. Did you skip school? Categorical covariate, and grades in school, which is a continuous covariate. Okay, so you'll see that we're going to build through these questions across today and tomorrow. But our first and foremost goal is, first, let's model the behavior. Let's identify the latent classes in our population. Okay. So we're going to address the first goal now. All right, so let's start with the data. The data set, I said, was from a large national study. They asked they did a very good job of assessing substance use behaviors. Just alcohol alone, we had a set of items we wanted to use. So let's take a look at our items. Did the adolescent report lifetime alcohol use? Have they ever had a drink in their life? 82% said yes. Okay, that's lifetime. That's an important feature. We also asked, have you used alcohol in the past year? Yes or no? 73% said yes. Have you used in the past month? 50% said yes in the past month. So that's more of like a current drinker status. Okay, so those are all just about using alcohol. Let's move to the level of use. So have you ever felt drunk, intoxicated from alcohol in your life? 57% said yes. 49% said yes in the past year. And 29% of them said yes in the past month. And there was an additional question that is in the past 2 weeks, so yet a different time frame. In the past 2 weeks, have you used 5 or more drinks in a setting? So usually it's a 2-hour window. Not quite sure how they asked it, but did you use 5 or more drinks on that day? So if you look at these indicators, there's a lot here. It's pretty comprehensive. There's more work in recent years looking at high intensity drinking in young adults and adolescents. That's 10 or more drinks. We did not have that on the survey. But we have 5 or more drinks, which is more of an operationalization of an intense drinking episode, a binge episode. We've got subjective feelings of drunkenness, and we've got whether or not they used any. And we've got these varying time frames of asking of how recently they did something. So this is drinking behavior broadly defined, right? we're not just asking, do you drink alcohol? Yes, no. That would be easy. We're asking all these different facets of the behavior. And so, what is the latent class variable I'm after here? I think it's important when you're starting out looking at potential variables to use to measure your latent class. I would challenge you to label your latent class variable. What is the latent variable you're trying to measure? And in this case, it has something to do with, it's all about alcohol use, right? It's alcohol use behavior, but it has to do with intensity and recency. Okay, so there's like, it's in that way, it's multidimensional. It's both intensity and recency of use. Okay, so I guess I would call it latent classes of drinking behavior, but I mean that in a kind of a broad sense, not just are you a drinker? Yes, no. I want to know the pattern of behavior around alcohol use.
So Stephanie, I got a really good question about indicators as a direct message that I think is relevant to this discussion.
Great.
So you just mentioned sort of the multidimensional nature of this example, looking at use and recency and kind of quantity in some sense.
Mm-hmm.
The question though is kind of twofold. One is, do you put sociodemographic indicators such as race, ethnicity, gender, SES in as indicators? That's the first part. And the second part is, can you combine indicators from different
Combine variables to create an indicator.
no, so for example, could you put in alcohol and alcohol use and reasons for use, something from different constructs into the same latent class model?
Yeah. Wow, great questions. So first I'll give you the technical answer. Yes, you can put anything you want in as an indicator, right? If you have the data, if you have the variables, yes, you can do it statistically. So really what we're talking about is conceptually and scientifically what makes sense. And that all comes down to what is the latent variable you're trying to identify in your data set? And what is the construct, the latent construct you're trying to measure in that population? And what indicators do you need to sufficiently map onto that to give you a chance at measuring that construct? So let's talk about the second scenario Bethany mentioned. So we have some papers that model. Oh, we're going to talk about marijuana use and attitudes, right? And that's going to be our example one. And so marijuana use and attitudes, we're including in a single model multiple indicators of use and multiple indicators of people's attitudes toward marijuana use. What is the latent construct we're after there? We're after marijuana use and attitudes, or what is a person's relationship with marijuana, basically, in terms of their own behavior and their feelings of whether it's ethical or health risk related feelings of its use. So we call that in example one, marijuana use and attitudes. You have to want to characterize people simultaneously in terms of their use and their attitudes. Otherwise, you would never put both of those types of variables in as indicators in the same model. You might want to have a latent class model that's characterizes behavior, cannabis-related behavior, and a separate latent class variable that characterizes people's ethical and health risk perceptions of behavior. And you could see how those are correlated, how they map onto each other. That might be of interest. But in our example, we wanted to know simultaneously within a person, LCA is often called a person-centered method, and this is an example of why. Within an individual, we want to characterize both their use behaviors and their attitudes simultaneously. And so in that case, yes, we put them together. The question about race and ethnicity, sex or gender, those variables in as indicators. You can do it. In rare cases, it might make sense to do that.
Yeah, I
Typically, I
want to
would
talk about
say,
that when you're
hmm?
done. I want to talk about that part when you're done.
That's great. Yeah. So if your goal is to take all sorts of personal characteristics, including demographics, with the goal of kind of sifting through all of it to look at what are the key types of people, kind of like an intersectionality framework, and looking for like the key intersections, sure, you would build a model that way. Most often, we're using LCA to model some sort of behavior or mental state or risk exposure. And then we're looking at things like race, ethnicity, gender, sexual orientation, things that are not malleable, typically as grouping variables or covariates. Go ahead, Bethany.
Yeah, so Linda asked a really interesting question about, can you make a latent variable for example, socioeconomic status? So
That's pretty
yes,
compelling, but go ahead.
yeah, yes, you can. So we could consider SES in multiple different ways. Let's say that you have a secondary data analysis that you're doing. They have one indicator for SES that's something like total household income or something like that. In that case, that's not really a latent construct, and you might just want to put that one variable in as a covariate, or maybe even a grouping variable if you chunk it up into different tiers. But let's say that your study, the whole research question of your study is to understand people who are experiencing different combinations of socioeconomic experiences. And you've asked maybe 6 or 7 questions. Do you receive WIC? Do you make more than $30,000 a year? Are you living above or below the poverty
Do you
line?
experience financial strain?
Yeah,
It could,
yes, can you meet your basic needs? Are you consistently housed? Things like that. That is assessing this latent construct of socioeconomic status, and you could get different topologies or different patterns of those things people are experiencing. And in my world of queer health equity, one of my really interesting conversations with my colleagues is, what is the best way to measure gender? Well, in lots of studies, we either have biological sex as simply male or female, or we have gender simply as man or woman or do not disclose. But if you truly wanted to understand somebody's gender identity versus maybe their sexual orientation versus maybe their gender expression, to me, all of those facets require multiple questions and a more theoretically matching approach might be to take a latent class model and identify different patterns of responses to get at different combinations of gender identity, expression, and sexual orientation. Or just even gender expression itself is multifaceted, and so maybe you get different patterns of gender expression activities, something like that. So the same variable in some sense, SES or gender, depending on your research questions and the data that you have available, is going to depend where, that's what's going to dictate where you put it in the model. Is it a latent construct that you're trying to measure? Or is it an observed grouping variable or covariate that you want to use to predict latent class membership? Okay, I'm done. That's my soapbox.
yeah.
Gender is complicated.
Yeah, so Alexis wonders if has a paper been published using LCA in that way, Bethany? If not, why haven't you done it?
Okay, so I haven't done it because I do mostly secondary data analysis, and many of the studies do not have acceptable questions. However, I do believe that there have been people who have started to look at that, and I will do a quick literature search over lunch. I don't have a good one off the top of my head, but I do believe there is one, at least one that's done that.
Okay, great. I'm going to punt the question about conditional independence until a little bit later this morning. We'll get to that. Really, really great question. A very important question. I will just say for this moment, we're looking at observed indicators on this slide, right? These are very highly correlated indicators, found like they have to be, because they're asking so much of the same kind of concept in these questions. In the overall data set, our indicators can be correlated. They can be highly correlated. The conditional independence assumption states that within latent classes, the indicators are independent. So we'll come back to that. But we would expect to see in any of these models, any of these examples we've been talking about so far, and there are so many more we'll talk about, we would expect the indicators to be almost across the board associated in the full population. It is the fact that people are in these different subgroups in theory that explains why we're seeing observed correlations in the indicators. Great. Okay, let's move on. So now that was our raw data. So now we hit the magic button and we run our model and we examine model identification, we do model selection, and out pops our neat little model here. So remember, our goal here is simply, the first goal of this paper was to identify and describe the underlying latent classes of drinking behavior in US 12th grade students. That's all we're doing right now. That's our research question. So let's take a look at what we found. You saw the raw data, so you can anticipate somewhat what we're going to see. Okay, here is our result. So this was the model we selected. 5 classes is what we selected. It was identified. And this is the set of item response probabilities, or the measurement parameters, you might say. So let's take a look at this and help us come up with, you can post in the chat here, come up with some labels for these classes. Feel free to pick a class and tell us what you would label it. Let's do the easy one together. The first, okay, we're already, yes. So remember what you guys got it. What we're showing here is the probability of saying yes to each of these indicators or items, conditional on being in the class. So class 1, if you're in class 1 and 18% are in class 1, they have a near zero probability of endorsing any of these items. So clearly class 1 is our abstainers, non-drinkers. So we're only measuring behavior here, not attitudes. So we have to label them accordingly. They do not drink, right? Non-drinkers, abstainers. Okay, class 5. Rebecca says alcoholic. Let's see, that's a strong term. But let's perhaps fair. We're talking about 18-year-olds, and they say, yes, yes, I have tried alcohol. In fact, I've tried it in the past month. Yes, I've been drunk. In fact, I've been drunk in the past month. So they've been drunk in the past month. They all said yes to that. 92% said yes to the last month. So very recent experiences with drunkenness. 73% have reported having 5 or more drinks in a sitting. So that is there are 34% of the population of high school seniors in the US that year were in this class. So again, I think, alcoholic is a strong word, perhaps, because it's a third of the high school seniors. But what would we maybe call these that would be a little bit of a milder frame that reflects this full third of our population? Maybe heavy and current drinkers. Yes, something like that. So Jessica says, 1, always sober. Yes, not just sober, but completely abstaining, right? Always sober. Former heavy drinker becoming habitually sober. Yes, former heavy drinker, or maybe they had one binge in their life, right? We know that they had one binge in their life, but it was not recent. Newly attempting to be sober, regular light drinkers. I like that. That's very descriptive. They are actively drinking, but not recent drunkenness, right? And binge drinkers. Yeah, so yeah, you've got it. So let's see, I think the next slide has some of our proposed. Okay, class 2, occasional drinkers. Class 3, regular drinker, recent drunk. Yeah, you guys are getting it. Very descriptive. These labels are not too sexy because they're very pragmatic here. But yes, so one thing that Bethany and I like to do is we often collaborate with people on substantive examples that we're not even the experts in the field, like obesity related behaviors, or for me, some like stigma, things that maybe I'm not an expert in. I might take the previous set of item response probabilities and replace the numbers with check marks or something like this, where I just mark the ones where they're above, say, 0.5. Bethany's got colored pencils or highlighters there. Yes, we do a lot of color coding. So yeah, mark high, medium, low, mark high, low, some sort of visual representation, so that you could go to a content expert and show this version of your item response probabilities and say, what would you label these individuals? What is an appropriate word to describe, or phrase to describe these individuals? Creating labels of the latent classes sounds a little trivial, but it is extremely important. Unlike factor analysis, where you're labeling a thing, a construct, a theoretical continuous construct like crystallized intelligence, here we're labeling people. We're labeling a type of people. And reviewers pay high attention to that. And we also have to be really careful that we're not being stigmatizing and misrepresenting the group. So we take labeling really seriously. Yes, describing the behavior, not the person. That's right. We want to be really careful in our language here. Absolutely. I agree, Carvella. Okay, so this is the kind of thing we would take to a content expert to get help on labels. Go ahead and forward, Bethany. Okay. So one more question. For items loading onto the classes, for labeling, is there a percent to use as a cut point? We're going to talk a little bit more about that as we go forward, Ashraf. That's a great question. In our example, can you go back 2 slides, Bethany, to see the numbers? In our example, thank you. We have a lot of zeros and a lot of ones. Remember, I said this was a very clean example. That's what I meant. There's a lot of zeros and ones in this table. This is a latent variable, but let's be honest, it's not that latent. It's not that hard to measure this from our 7 variables. So in this case, it's pretty easy to think about how you would mark like what's high and what's not high. And I think for me on this grid, I would just use like a 0.5, because it would so clearly differentiate which ones are more elevated relative to the other classes. In some cases, you're going to have an indicator. Let's say that we had one more indicator on this model, and it was that you've been diagnosed with alcohol use disorder. Like you have been clinically diagnosed with alcohol use disorder. I can tell you what those item response probabilities would probably be in this data set. If we had asked that question for class 1, it would have been 0. Class 2, 0. Class 3, 0. Class 4, 0, for sure. Class 5, among those third of partiers in high school, how many had a clinical diagnosis of alcohol use disorder? I'd say it could have been under 10%, right? Maybe 10%, let's say. The fact that it being diagnosed at that age is even probably less common, but it will be very low, but it will be non-zero. And so if you have an item like that is very rare in the population at large, but is elevated in one of your classes, that's important. And so if you just kind of said, well, if it's above 0.5, it's meaningful. If it's below 0.5, it's not meaningful. You'd miss that really important feature of like, yes, these are partiers. These are current partiers in high school, and 10% of them have an alcohol use disorder. This kind of comes back to Rebecca's labeling earlier. Like that would indicate that a subset of those partiers really have a problem that's diagnosed. And so that 0.1, that 10%, I would absolutely want to mark it, flag it. That's part of the label. Those very at-risk kids. Yeah. Hope that helps a little bit. It's arbitrary though, and it depends on your example, and take it as a whole. Like we're trying to interpret this matrix. We're looking at each item and how did the items differentiate. In the example of a diagnosed alcohol use disorder, that item would look very different than some of these other items that are 0, 1, 0, 1, right? We think about it at the item level. We think about it at the class level. For a particular class, how do we interpret them, right? So for an item, what do you think the item is doing? Does that contribute to the labels? For the class, how do you look at it across items and think about labeling it? We're looking at it as a whole. Yes, you can graph these for sure, and that may be very helpful. We'll probably show a few examples of that. And we can certainly pull some up from the literature to show how a lot of people will graphically display a matrix like this. That can be really useful.
The
I
other
prefer
thing,
that. Yeah, I like the table a lot. I think keeping the table in your manuscript is really nice because this shows the actual parameter estimates. But having a figure can also be really helpful. Bethany.